Every second, the modern enterprise network generates millions of connection logs. It is a chaotic blizzard of IP addresses, ports, and timestamps, making it incredibly difficult for security teams to see what is actually happening in their environment. Raw network data provides a pile of logs, but actionable insight requires structure. Staring at a list of unstructured information is not the same as understanding a threat. Cisco Secure Network Analytics, or SNA, is the platform designed to bridge this gap. It takes that massive volume of raw network telemetry and turns it into precise visibility. Instead of drowning in disorganized data points, SNA structures them into a clear, readable stream of critical security context. True network security is built on systematically transforming targeted telemetry into investigation context, rather than simply collecting infinite data. The process begins with the infrastructure already in place. Natively, your routers, switches, and firewalls export standard flow telemetry, formats like NetFlow, IPFix, and SFlow. Flow records reveal network conversation physics: who communicated, where, when, and how much. Cisco ISE enhances this by attaching user and device context. Outside the perimeter, Secure Client NVM supplies endpoint telemetry, revealing specific application processes and remote behavior. Integrating these layers ties network activity directly to identity and policy. Analysts can identify the specific contractor behind a connection and verify their behavior against security groups. By layering ISE and NVM context onto raw flow data, SNA builds a comprehensive, deeply searchable security narrative out of basic connection records. Moving and managing this enriched telemetry across a large enterprise presents a serious logistical challenge. Cisco Telemetry Broker acts as a central control point, filtering and routing the incoming telemetry. Flow collectors then receive these streams, deduplicating redundant logs and stitching related records together so they are ready for security analysis. The telemetry capacity the deployment can analyze is dictated by the flow rate license, making flow rate and overall scope crucial variables for sizing the system. When an environment requires massive scale, centralized storage for better query performance, or extended historical retention, an optional data store is added to the architecture. All process data ultimately converges at the SNA manager. This is the central experience where the user interface lives and analysts conduct their investigations. This component chain ensures the right telemetry is collected, refined, and delivered to the analyst at the exact moment they need it to track threats. Successful SNA design aligns architecture strictly with desired security outcomes, rather than simply deploying every available sensor in every possible location. For example, an organization focused on detecting lateral movement must prioritize internal network telemetry and map out east-west traffic paths. If the objective is visibility into a remote workforce, the architecture requires Secure Client NVM to capture endpoint telemetry. Validating network segmentation requires a design that leans heavily on gathering groups, tags, and policy context from ICE. Dumping more raw data into a single location does not automatically generate better security outcomes. The true value of a security architecture is measured by how quickly an analyst can retrieve the concrete evidence needed to prove the outcome they care about. When all these discrete parts are perfectly aligned to a single purpose, the result is an orderly, synchronized system that delivers clarity without congestion. The strongest SNA architectures begin with a specific visibility gap and then select the exact telemetry needed to close it.